So far we have discussed the software development process and also motivation for why you want to catch defects in the design phase. And also we define what it really means for clients versus supplier and also contracts, and eventually design by contracts, which is good practice to really guide your design process. So now we want to look at DBC, design by contract, specifically to see how you can support it in the language that you're familiar with, Java. And then we'll see its limitation, because Java is really meant to be a good implementation language only, not really for design. That's something we would like to illustrate to you and convince you. Okay, so our first attempt is to really give you a problem like a requirements, which is meant to be incomplete, ambiguous, or even contradictory. So we'll see just as another example. We'll try to implement some requirements, and then some others will be left. But those of you who might be interested in doing some further exercise. So this slide will summarize the problem that we're trying to solve. So we're going to solve a simple bank accounts problem. Okay. So requirement number one, eventually we have 1, 2, 3, 4, 5, and 6. We got 6 requirements over here, but for the purpose of this lecture, we only do requirements number 1 and number 2. For 3 until 6, if you look at the end of the lecture, beyond this lecture section, I already gave you some possible exercise for those of you who want to explore further. I highly encourage you to actually do it for your own benefits of learning. So let me just go over with you requirements 1 and 2, just to get yourself familiar with what we're going to develop. And we're going to have a series of versions to actually introduce to you the ideas about the design by contracts, precondition, post-conditions, and class invariants. So requirements number 1, we are basically talking about each account is actually associated with the name of the owner and also an integer balance that is always positive. So if that's always positive, it should be strictly larger than 0. You can do a little bit of formulation over here. And we also got requirements number 2 over here. So we say we may withdraw an integer amount from an account. Okay, so now if you only read the requirements, let's say if this is the problem I give to you, so is it really precise and unambiguous enough for you to do implementation right away, or even to do design? The answer should be no, because there are actually quite many missing details intentionally over here. But that's okay, so we're gonna just guide you through the process of doing it. Based on this, I'll propose the version number 1 of our Java implementation. We'll go over the code with you, which is quite simple. It's not that many lines. And then I would suggest you pause the video and think about what issues that you might have for the first proposed design. Okay. So let me go back to the slides. So now and then we'll try to implement requirements 1 and 2 only. Again, for 3 until 6, it will be left as exercise for you. And the implementation or design may not be as easy as you might think. So we're going to eventually present to you 5 versions of the Java code. So when you go from version 1 to version 5, so you should always stay on top of the picture. So always think about what's really the design by contrast ingredients I'm adding to my Java code to make it better. Okay, eventually we'll get version 5. Okay, I will also suggest, even though we're going to program Java on the paper, but everything does work on Eclipse. So I would suggest you download the source code. You can simply click on this particular link on the lectures website, and you can download this Java archive file for the projects and download and try that out. And in order to do it, you will have to import the projects. And if you're not sure how to do it, you can look at this tutorial video. And also, we're going to use assertions to encode some contracts. And to really enable assertions in Eclipse, you can also follow this particular tutorial video to make it work. I highly recommend that you actually try this example here in Java, just to really appreciate why doing design indirectly in Java by lots of manual encoding is not that convenient, and it's not really the best way to learn about design. That's why we are choosing another language called IFO, which can do everything we're gonna say that's convoluted in Java. We can do it neatly in IFO. Okay, so version number 1. So we're just gonna introduce an account class. let's say we say account version 1, so I say account v1, so it's going to be the naming convention. We're going to give v1 until v5. We have two attributes, owner and balance, string and integer, and now we have some accessors here. We can get the owner, we can get a balance, and then we have a constructor here. So given owner, given balance, we're just going to initiate the owner's name and also the initial balance. And then we have one mutator method here. We only worry about withdraw. Let's say you can set some initial balance and then you can withdraw some amount. And then with the way to do withdrawal is by deducting the input amount from the balance. Looks fine. And then we also got some toString method here to see what the current balance is for the account. Okay, that's it. So I claim that this particular account version 1 is a good intention of implementing requirements 1 and requirement number 2, more or less. Now, do you think if there are any issues over here for account version 1? Okay, I would suggest pause the video now for yourself, and then when you resume again, I will talk about what the issues are. Okay, so hopefully you already thought about what the issues might be. There are at least 3 issues over here. Okay, I'll just sketch them very quickly, and then we'll talk about them one by one. Okay, for now, I'm not going to show you on Eclipse. For this particular lecture, I will only show you a little bit of Eclipse later, if time permitted, when I talk about post condition. But for others, it should be quite easy for you to reproduce and also experiments in Eclipse, since you have taken many Java courses already. Okay, there are at least 3 issues. Issue number 1. For the constructor over here, it has no constraint whatsoever about what the balance could be. What if it's negative? For example, that means I will be able to initiate an account with negative balance, let's say minus 100, right? So that's issue number 1. Issue number 2, for line number 9, for this withdrawal method over here, the integer amount here also was not constrained at all. So that means I will be able to withdraw minus $1 million. Should that be allowed? If that should be allowed, let me know. If such a bank, let me know. I'll be very interested in joining them. So this is the second issue. You can actually withdraw a negative amount. And issue number 3, similar to here as well. Let's say I do pass a positive amount. However, is a positive amount always should be allowed? Maybe not, because let's say I currently got $200 in my account. Should I be allowed to withdraw $1 million? $1 million is actually positive, but it's not affordable as far as my current account is concerned. Okay, so these are the 3 issues. And then I'm going to illustrate each one of them with you, and then I'll talk a little bit about why it is not a good design. Remember what I said before in the previous slide. You can look back to the slides. A good design means if there's anything that goes wrong at a runtime, it should be exactly one party, either clients or supplier, that should be blamed. If it's unclear about responsibility, then that means your design is not appropriate, not ideal, and it should be fixed. Okay, the first one. The first one is it violates requirements number 1. If you recall, the requirements number 1, we actually said over here, it should be always positive. So if throughout the lifetime of any account objects, if its balance is ever non-positive, then it should be considered as invalid. Okay, that's the first issue over here. So let's take a look. And this requirement is now reflected in the above Java code. Let's see how. Okay, let's see here over here. So you can look at the Java code over here, and then I'm just going to illustrate to you. Okay, exactly. This is one use case, but to really let you see the clear picture, let me switch to iPad. Okay. Again, you should really know about who the supplier is and who the client is. And this is the version 1 of Java code that we just talked about. We'll revisit this fragment of supplier's code a little bit later. Let me just make a note over here. So this is the supplier of the account. So somebody, well, some other class is actually going to make use of account version 1 by calling its method, for example, withdraw. Okay, so now let's take a look at the first issue over here. Again, remind yourself that this particular account version 1 is actually the supplier, and this let's say we got another application class version 1. That's the clients, the user. Okay. So now again, in order to really have a client-supplier relationship, we have to declare the supplier objects. For example, you can see here, account number 1 is the type of the supplier, and then this is the name of the supplier, right? So this is the supplier. And apparently, in the context of this class, we are making a method call. So this is the clients. Okay? So it's just a reinforce what we learned in the previous part of the lecture. And then over here, you're simply calling this particular method like a constructor. Constructor is a special method. And then we are basically calling this particular constructor over here. And then we are calling that with -10. So that means we're going to set the balance to be -10 over here. Okay, so hopefully everything is clear to you. And in the post states, remember we talk about pre-states and post states. So pre-states is immediately before calling the constructor, and the post states will be immediately after the constructor is executed. So this is the post states, let's say. But now the post states is actually invalid because now the balance for Alan has been set to -10. Okay, so post state should be invalid. Okay, so that's why we're going to output to say Alan's current balance is actually -10, which is invalid. Okay, so now you can see how the first issue actually occurred. So every time later on, whenever I give you some open-ended problem about some proposed design and then want you to criticize on that, if you do believe a particular given design is actually inappropriate, you always have to give examples like a witness, like a counter example to show that the design might behave badly at the runtime. Okay, let me come back here and then let's discuss this first issue over here. So it's possible to actually have a negative initial balance, which means the object states. Whenever I talk about the states, that means all the values for the attribute that's the states for a particular object is invalid because it could be negative for the balance. And now that'll be violation of requirements number 1. If I just remind you very quickly, requirements number 1 over here, it should be always positive. It's a violation for the requirement, so that means the design is not good or the implementation is not good. Now, what's really the issue over here? In this case, should we blame the supplier or should we blame the clients? So let me come back here. So again, should we blame the supplier over here or should we blame the clients over here? Which party should we blame? In this case, I would say this poor design, the first version here, it seems like we should blame both of them. Let me tell you why. Why should we blame the supplier? First of all, let me talk about client first. That might make more logical sense. Why should we blame the clients? The clients is over here, and the clients is actually trying to call this particular constructor here, but the clients is so careless. They are passing a negative input to initialize the account. It's almost like when you actually want to use a microwave, you put something that's explosive to heat up in the microwave, right? So now you can think about the clients should be blamed because -10 is illegal. It's going to result in a negative initial balance for the account objects. So definitely the client should be blamed. However, somehow you can also argue that the clients class was somehow misled by the supplier class, because if you look at the interface for the supplier class, which is here, let me be very precise here. So now if you look at this particular method that we are talking about, let me use thinner. So if you look at the header, which is the header for this particular method, you can see that this is the header. Does the interface of the constructor anywhere actually states that the balance over here should always be positive? It does not. It simply say as long as it's an integer, then you'll be okay. So the supplier should also be blamed because they were not clear about the instructions of using this method. It's almost like the microwave manufacturer, when they deliver the microwave to you, the manual over there doesn't really specify explicitly that you shouldn't put anything that's explosive, something like that, right? So supplier should also be blamed. So let me write it down to be clear. Also, supplier should be blamed because the interface does not specify the constraint, input constraint more precisely. Okay, so I already argued that in this particular poor design, it is really inappropriate because when something like initial balance being negative happens, both parties should be blamed. So that's not good. It should be exactly one party that should be blamed. It should be exactly one. Okay, let me go back here. And then, so now, as I explained, both should be blamed. And so for the clients, they actually pass an invalid balance, which is not good. They didn't use the method appropriately. However, the manual or the API for the supplier, they also didn't specify that precisely. So that's the problem. Okay. Hopefully you can see what the first issue is. The next two issues are somehow similar, so I don't have to explain this many detail, but let's still go over them quickly. The second issue, which is my favorite, which is you can actually withdraw a negative amount. Let's see how. Okay, so this again is the code. Let me illustrate to you quickly. Okay, so now if I go back to my iPad over here, so now let's see this. So we still have this particular supplier objects over here, and then we simply initialize the object to be initial balance will just be 100. So far so good, right? This time at this point the client is behaving well. However, this particular method call over here, again, let me remind you, the mark is actually the supplier objects. And then the withdraw is also the supplier method. And now this input over here is minus a million. Okay, apparently, as we said before, this will be invalid. If you believe that should be valid, find out such a bank and let me know, please. I would love to join them. So this is also invalid. And the issue that we argue is, okay, and then we can see initial balance being 100 after this, and then the resulting balance after withdrawal will be $1,100,000. Okay, so now which side should be blamed? In order to be a good design, it should be exactly one party to blame. But again, we can blame two parties. Okay, I'm just gonna sketch it out verbally, but the argument will be very similar to the previous one. Okay, so now both parties should be blamed. Number one, you can see for this particular invalid input value over here, this tells you that the clients should be blamed because they should have passed some positive amount that's affordable, right? At least it's positive. And also, if you look at the withdrawal method over here, if you look at its interface, let me highlight it. It simply tells you can just withdraw any integer amount, including negative. So the supplier is also careless. They were not precise and complete enough about what can be passed as input. So, and also supplier should also be blamed. Okay, so similar arguments. So hopefully by doing the arguments in detail, also you can also pick it up from such skill about justifying why a design is either good or bad. Okay, so now similarly, so the account state is actually valid. If you think about 1,100,000 is actually a valid state because it's always positive as far as requirements number one is concerned. However, if you think about requirements number two over here, let me go back there. You can see that over here, requirements number two, we should really do withdraw. And of course, the requirements is not being very complete or unambiguous about what you really mean by withdraw an integer amount. But I would say if the customer has some common sense, they really meant to say, even though they didn't say it explicitly, that the integer amount should be positive at least. Okay, so it's a violation about requirements number two. Okay, again, it's a lack of contracts between over here, the clients and also the supplier. So both of them will be blamed. So it's a poor design. It should be exactly one party that should be blamed. Okay, so now finally, let's take a look at version number, the third issue quickly. Okay, the third issue is about, let's say the withdrawal amount is actually positive, but it's not affordable. Okay, let me show you quickly on over here. Again, that's the code to actually show you, and then let me illustrate to you again on iPad. So that's the third issue here. Let's see how that actually happened. Again, we have the supplier objects. Okay, and then we're calling, and then initially we are passing some legal initial balance for the account object to be created, and this really is the issue. Okay, again, this is the supplier objects, and we're using the withdraw method from the supplier class, right? Remember, supplier is here, and also clients is over here. And now, given that the initial balance is actually 100 for Tom, and now we are withdrawing Tom from his account 150. Apparently, it wouldn't make real sense, because how can you do that? Otherwise, you can always withdraw $1 million from my account. That would be also very useful. So now, when you actually execute the Java code, it will show you that initial balance, the resulting balance from the withdrawal will just be -50. Again, it violates requirements number 1, because the account balance should never be negative. Again, who should be blamed? Well, hopefully now you can also make an argument yourself, right? Let me just mention that again quickly, and then you should really try to detail the argument yourself as a practice. Thinking this way, the client should be blamed because 150, even though it's positive, but it's way too big as far as the current balance is concerned. So the client should be blamed on the one hand. On the other hand, the supplier should also be blamed, because you can look at that's the header or the interface for the method. However, there's nowhere in the interface does it say that the amount over here should be positive and affordable. It doesn't say it. So the supplier should also be blamed for not being so precise and complete. So both the clients and suppliers should be blamed. Okay, that's the third issue. Okay, you can also read it through, and that's exactly what I just illustrated. So far we actually have seen for version number 1 that we actually talk about over here. You can also, before you go to the next part of the lecture, please review this version number 1. It's without any contracts. Or in your Java course, you learn about some primitive error checking using exceptions. You don't even have exception handling over here. So starting from version number 2, we're going to see how you can use exceptions that you learned from your previous Java course to actually approximate the implementation for contracts and to make the version better and better. Okay, stay tuned.